I'll be trying to solve the answer. What is the limit or the value as the limit of x approaches 0 of 5x to the power of 3 over sine of x minus x? Okay, so we're just gonna see if we get a value just by plugging it in. So as we put 0 for x, sine of 0 minus 0, we see that this will give us 0, and this will be 0 minus 0, which is 0. This is an indeterminate form, so this means we can apply L'Hopital's rule. Okay? So when we apply L'Hopital's rule is when we take the derivative of the numerator and the denominator. Okay? So applying L'Hopital's rule as the limit as x approaches 0 of 5x to the power of 3, this will give us 15x squared over the derivative of sine is cosine. Cosine of x minus, and the derivative of x is just 1. Okay? So now what we have is to apply our zeros to our x again. So we will have 15 of 0 squared over, so if we apply 0 here, that means it will give us a positive 1 minus 1, which is still 0 over 0, which means we still have to apply L'Hopital's rule for the second time. Okay, so going back where we were, over here, we have 15 times 2. That will give us 30x over the derivative of cosine is negative sine of x. Okay, and well, the derivative of negative 1 is just 0. Okay, applying our, oops, I almost forgot my limit. There you go. Applying our limit again will give us 30 times 0 over negative sine of 0, and this will give us 0 over 0 once again. Okay, so that means we have to do a derivative one more time, or it's not the derivative, but our L'Hopital's rule again, because it's an indeterminate form. So the third times the chance, right? So the derivative of 30x is just 30. The derivative of negative sine is negative cosine of x. Applying our limits as x approaches 0, we'll get 30 over negative 1, because if we apply 0 there, we equal to 1, giving us this negative 30. And that's our answer. Thank you.